Okay, looks good. Hello everyone to another day where we make a game engine in Golang from scratch. So I know we said we won't do any more Flappy Bird, at least for a while, but I thought, you know what, let's finish up the last to do we had left. And as always, let's look at where we stopped last time. So we had Flappy Bird basically fully implemented, more or less. But one major thing we don't have was sound because we still haven't implemented anything for nMage. But what I did was work on kind of a separate library which we can use. It doesn't have to be. Maybe later on we'll expand it for nMage, but made a separate sound library that we can use in Golang. Right, so it's based off. It uses auto under the hood, but it's more high level. It's a lot simpler to use, and supports, as far as I know, more audio formats. I don't know, you can expand this easy. So my main task for today is we should just take this wavy, which you can find github.com/wavy, and kind of integrate it into Flappy Bird. Yeah, I already have some sounds. So I have a bunch of MP3s, one for dying, for getting a point, and then for jumping, essentially for flapping the wings. Now, let's get wavy added to the project. And then it shouldn't be more than a few lines of code, that's it. So while this is loading, we need an init, and then we can immediately just load a sound, set a volume, and play. And we can either play in the background with async or play synchronously. So I think I'll just take these two lines. There we go, we have wavy now. And let's load our sounds as usual on init. So let's say, sounds. So we'll do this guy. So we have a 44 kilohertz sample rate, very standard for sounds, and then stereo. So we have two output channels, stereo, and then I think 2 bytes per sample, right? So these are very same defaults. This is usually what you would find. Otherwise, I guess we can panic. Yes, that's what we do elsewhere. And then we can just start loading sounds. Now, we can either load in memory, so we load the whole sound in memory and then play it, or we can stream it from disk. So maybe we have a very large sound file, like a very long music file, for example. We don't want to load the whole thing into memory. We want to just, like read data off disk as we're playing. And that uses a lot less memory, but if it's a small sound or something you'll play a lot, like maybe gunshots, or in our case, jumping, you might want to just load it into memory. For us, all the sounds are very small, so doesn't matter. So what I'm going to do is, resources. Now we have a sounds folder, and we just load all three. Let's start with wing. So I'll just call it maybe jump mp3, and then maybe score.mp3. Right, and perhaps we can do this. So something like jump sound, and all these sounds are just a wavy sound. That's it, all of them, no matter what the format is, it's always wavy sound. So we have a jump sound, we have a score sound, and we have a die sound. And then, so this guy is jump to the mp3. So we have jump sound, and I will just replicate this here. let's load this core sound. That's the so die. Now if we run, hopefully we don't crash. Cool. So these sounds are loaded. Now all we need to do is just play them, and we can play as many times as we want. So Wavy gives you the ability to essentially play a sound, and then you can rewind or just like seek to, let's say, the middle and then play from there, things like that. So in our case, what I want to do, let's start with jumping. So what do we have in updates? Okay, we call playing. If space is clicked, so here's what we'll do. Let's do jump sound dot play. We don't need to wait for it to play, so just play it, and then so when it finishes, so if you press twice, like jump in 2 consecutive frames, then the sound might still be playing, and what we want to do is potentially just rewind. Even if there is one already playing, we just want to stop that and then play again. So perhaps we can do a reset. Is it? No. Seek to time or seek to percent. So let's go to 0%. Right? We go to the beginning and then we make sure to play again. So even if we're playing already, this should do it. And yeah, we'll try. I hope the sound is not too loud for you guys. Okay. Yeah, so you can see how it's kind of clipping. If I press a lot of times, because it's trying to continue to play, but then we seek to the beginning and it kind of restarts. I think that's okay. One other thing you can do is just to actually let the first one continue playing and then play another one. And the way we can do this is we can actually, since this is in memory, we can do a clip in memory sound. So we can say, jump sound from 0 till 100%. And then, seek. Now what we are doing, since this is in memory, the same sound without copying it can be played from different places. So for example, I'm shooting a bullet 10 times, or here we are jumping twice in a row, right, very quickly. So we want to keep the original sound playing, but then play the new sound, the same sound from the beginning. So one kind of simultaneously, we're playing the sound from the middle, but also we're playing it from the beginning. Now we can do this using something I call a clip in Wavy, because all we are doing, we're not copying data, all we're doing is just setting some indices internally. So we're saying, more or less, give me a copy of the sound from 0% till 100%. And I think it's between 0 and 1. So if I do like 0.5 till 100%, I'm going to get a sound that only plays from the middle, right? When I go to the start, it's actually the middle. In our case, we want to take the whole sound, make essentially an independent copy of it. So even if another one is playing and it's now halfway, it doesn't matter. For us, we're going to play another one. Let's see how this sounds. Maybe it's there shouldn't be any clippings. Yeah, this is much better actually. Oops. Yeah. This is very nice. Much better. So even if we have multiple jumps, we'll play just multiple times. Cool. So that's it. Just one line of code to load the sound, and then if you have overlapping sounds, then we can clip them. And this clipping is extremely cheap, so there is basically no performance in doing this. Right. So what else do we have? We have dying and we have scoring. Both of these, I think, we don't need this. We can just play them directly because they only happen once for dying, and then every now and then, like, it takes a long time for you to reach the second score. The sound should already finish. So where do we do score? There we go. So score plus plus. So when we increment the score, let's play a sound. So score sound dot seek. Let's go to the beginning of the sound, because if we played it previously, right, so it's already at the end. We cannot play it again. It's already at the end, so we want to go back to the beginning and then play again. Okay, then so we seek and then just play asynchronously. That should do it. And then for dying, lost, so we only want to do once here. So when we change the game state to lost, going too high, yeah, so we can do this, or so we have it here as well. We should break here. If we lost, no point in continuing to check. We should break. Here as well. Once we have detected a score, you cannot score more than once. We can just break as well. Right. So perhaps maybe we can do like play this sound. Not really. After all the processing is done, all we need to do is check if the game state is lost, right? Then play the sound. That's it. So this sound, just to handle restarts, I'm going to seek it in case we died, restarted the game, and the sound has already played. And then play async. That should do it. It's so nice having sounds. It's like when you first add graphics. Okay. Nice. There you go. And on the ground as well. Cool. So I think that's it. That's all we had to do for Mr. Flybird. We have sounds now. I really like how Wavy came out. It's really simple. And I'm pretty sure we can build on it. So if we want like 3D sounds or more controls, things like that, then we can definitely expand on this. But it's a very good start. And with this, I think we can just do sounds. We can push Flybird, and that's it. We're done. Now, I'm not sure what I wanted to do other than this for today, because I had a bunch of ideas what we should be focusing on next. So this is nMage, and if we run we have our own, the old projects. We have all these 10,000 or something cubes that rotate with some simple lighting, no shadows, just lights. Yeah, so we have this now. There is, I guess, a lot to do, but the importance is definitely not the same. We can still, make a game even if we didn't have like a scene graph or things like this, if we didn't have frustum culling. But some things are kind of more important potentially. Like camera class is really useful because the camera is annoying to use, the setup. And entities, so I'm very conflicted about doing entities because it can help with performance, but not really. But it would also potentially enforce a way of using the engine that can be more complicated. So since we don't have entities right now, what people would do is everyone would go basically on their own and implement entities. So in Flappy Bird, we made an entity class that had essentially a transform component, right? But what if we also wanted, our entities can also have a mesh or a sprite attached, which we do, right? But for now, like in Flappy Bird, those were separate things. Let's look at, what is this? So our bird was separated into multiple separate things that we were dealing with individually. That's obviously not very nice. But yeah, like we had our kind of bird physics. We have a bird sprite and a box collider, all different things. Now you can make potentially one kind of bird struct, and the bird would have an entity, it would have an entity inside, inherit all of these, and then it would have all the components that it wants. So it wants entity is already a transform component, then you would have like a quad and box collider and all these things. So you can deal with them as an object, and then the pipes would be similar. And we already did this for the pipes. So for the pipes, we did, I think it's in quads, right? No, we had, where is it? There we go. So that's what we did here. That's essentially a game object. Now the question is, what do we do for the engine, for nMage itself? We can go something similar to an ECS, an entity component system, if you guys have heard about it or not. I'm very conflicted. Because our decision here will kind of change what this means. Because what if you don't want to use an entity component system, right? It's definitely simpler to deal with just normal objects. So the simpler this is, the better it is for users. Not every developer is going to want the highest performance or going to know all the details. And I think that's one of the reasons why things like Godot and even Unity are very, very popular, because they don't follow this. At least they don't force it on you. Some people would switch to an ECS, but most people just do game objects and things like that, because very, very intuitive. So not sure. Karma class we can definitely do potentially today. Shouldn't be very complicated. And then we can keep thinking about this guy. And now that we have sounds, it's basically usable. It's a very it's simple, but you do have a lot of the fundamental components that you need, for sure, in nMage. But yeah, I would like to develop it more, have some high-level features than what we do have right now. So, I mean, let's perhaps do a a camera class. Let's do a camera. Where should we put it? Engine, not really. Renderer? No. I mean, let's do a camera package. Camera needs to be .go. Camera, and then just camera. I think the linter will complain. But what? Okay. So let's see what we're doing now for the camera. The view matrix. So a camera is going to either be projection or orthographic. And right now, this is essentially our projection matrix. And we also have, an orthographic function with different set of functions, parameters, right, that are required. So all we need to do, and then you have a position and you have a camera forward. So, where you're looking and what your forward is, it's really a mess. So someone needs to know all of these details. So I'm just going to essentially take all of this complexity and then move it into here. So I just put this to keep in mind the things we want. Let's see. So I do want a type, and this is already under the camera package, so I can just do type. So camera.type, and this is just an integer. And there too. So what do you call it? Const. So type underscore perspective. I hope this is the correct way of writing it. Type equals that. We can do n1, right? N1. Just so the default value is kind of orthographic. I think this is wrong. Let's see. That's correct. Okay. Orthographic camera or perspective. That's all we have. So our camera is going to have a type and a position, which is going to be glm.vec3, and definitely a rotation, I think, or just a forward. Yeah. View matrix. Yep. The view matrix, we can cache the view matrix, and only when things change we can recalculate. But we have a camera position and camera forward. Where we're looking. And let's see. Okay, what's the last parameter? World up, right? World up we can take, I think, or we can hard code. Okay. And then let's see, what do we do with the camera? In movement, we just adjust the position, and then we update these parameters. Okay, now this is a bunch of things here. And we're going to need all the parameters for orthographic as well. We can just put everything in one class, to the matter. New perspective. Can even do this because camera dot new perspective dot new. Yeah, sure. And then let's do this. So for perspective camera, I mean, you'll probably want to pass us the position. Like 3, and let's see, glm dot perspective. Okay, so it is wrong. FOV, right? So we'll want an FOV, which is about 32, I think. Aspect ratio and near clip far clip. Yeah. So all the data for perspective and then all the data for this. So for perspective, we have FOV and we have aspect ratio. And what else? Yes, near clip, and far clip. Let's just everything public. And yeah, let's do near clip and far clip. All we'll do is this, and then aspect ratio, near clip, and far clip. And then in both cases at the end, cached view matrix, right? We're going to have one matrix form. Right? Like this. That should do it. So let's see. In cam dot. So type, perspective, position, we have it. Forward is, you know, what's our camera forward? It's looking on the z-axis, right? We might want that. For now, I'll just do new like 3. Okay, and then, you know, FOV, aspect ratio, near clip, far clip, and view matrix is this guy. Dot data. No, dot mat4, is it? Yeah, dot mat4. Why is that? Oh, it already gives a mat4. Okay. Right. Position. And what I'm going to do is let the user play with this, but then ask him to update. So our view matrix is only going to be recalculated when you tell us to change one of these, essentially. That you change them, right? Because I don't think it... Yeah, I don't know if I want to have functions like, okay, update FOV, update this, update that, doesn't matter. We're going to give, and we can obviously always change it. Humat, or just update. And all that's going to do is do this. C.viewMatrix equals this. C.FOV. So if you change any of these, it's fine. C.aspect ratio, C.clip, and C. And that's it. And probably, we want to check if type equals perspective. We'll do this. Else, we'll do something else. We will do orthographic. Okay, so I think this is good. I think far clip, near clip, so on. I think so. Okay. Now what we can do, where are we using this? Target position for lookat. Yeah, lookat might want that as well. That's very common. We can integrate this function into the camera class as well. Just have a wrapper essentially, because that's very, very common for you to say, well, make the camera look at that thing. In which case we can just do lookat and C.viewMatrix mat4 position. We know target position, you'll tell us. So target is like 3, and you give us your rolled up. That's that. But what should we do if it's an orthographic camera? We can give an error, or we can force the change. We can ignore. I mean, we can assert for now. And where is it? Assert. I don't like it called asserts. Just assert. Let's do assert. Things will cry now, but yeah. And consts. It's not really this debug true. Okay. You're not using asserts anywhere? That's weird. Anyway, so we're going to do assert dot nMage assert. We're going to make sure that the type is perspective. Otherwise, we can say calling lookat with a non perspective camera is not allowed. Right? So when you're developing, you will know for sure. I think this is the best solution. So now we can do func new orthographic camera. And same thing, we're returning camera. Okay, and return cam. Now in orthographic, and we can look at Flappy, since there we use an orthographic camera. Let's look at camera stuff. Setup camera. So same thing, we have position, target, looks like. Oh, right. So we have the view matrix and the projection matrix. This is one of the reasons why we need a camera class. These are two different things. And look at this, the view matrix, not the projection matrix. That's correct. That is correct. Yeah. View matrix we always get from lookat right now. That's the only function we have. So I guess we can always request a target to look at in all cases. And we'll need a view matrix and projection matrix as well. View matrix, projection matrix. So here we have a cache of things, and we'll take this and the target position. And we can cache this as well. So targets. So this is actually our projection matrix. And here we have our lookat matrix. I guess we can keep this just to make it simpler, because this might be used a lot, right? And this assert doesn't make sense anymore. That's wrong. And cool. We can ask for world up. Should we? Oh, we didn't use it here. Sure. World up. And yeah, world up. Why you? Oh, yeah, you said. Wait, when? World up. Oh. So I actually move these in there so we make sure that we're actually setting the camera, everything. So what do we have? Targets is target position. World up is world up. View matrix and projection matrix, last two things. So now we will do camera dot. View matrix is just the lookat, and we'll use camera dot position. So I want to make sure we're using the values from here to ensure that we're actually setting them. And then camera dot targets and camera dot world up, right? And then that gives us a matrix for similar thing for projection matrix. Perspective, camera dot FOV, camera aspect ratio, and then camera dot near clip, camera dot far clip. Cool. That's it. Just these. Bunch of the things are still there. So these ones are still there. Right? And then we're not setting these. The type is orthographic. And let's see. Now we want these guys. Are we doing anything special with this? No, we just searched once on startup. So near clip, far clip are still there. Okay, just use all of those. Since these are common, I'll just move them forward. Near clip, far clip are always there. Then we'll put the different ones. Near clip and far clip 2. Near clip, far clip. Right. Now we have here we need two things. For orthographic, we need a bit more ortho. For orthographic, we want all of these as well. Left, right, top, bottom. Maybe we can simplify the API, but we could do it later on. Maybe. At least it's combining all these different variables and steps into one place, so you know exactly what you need. And then we can replace our original camera with this. Okay. Now, all orthographic. We'll do left, right, top, bottom, near clip, far clip. And oh, you actually forgot to set them here. Left, right, top, bottom. And left, right is right. Then we have top and bottom. And now I just use the ones from the camera. So camera dot right, top, bottom, and here as well, camera and camera. And I think, yeah, let's move these guys up. Cam. Cool. Here perspective, here look at, and in update, we can do this. In update, we can always do the view matrix thing. But the orthographic part changes. Yeah. So you probably, change properties, like change the position or do whatever you want, and then just call .update. We can say update recalculates view and projection matrices, right? You might want a pre-multiplied view projection matrix, so we don't have to do it on the shader itself. Maybe, right? Because right now for every single object, this multiplication is happening per object. But the thing is, projection into view matrix never changes. That's always the same. Just the model matrix is changing. So instead of uploading these, we just upload a projection view matrix pre-multiplied. I'll leave that for now. If the user code wants to do that, they can. But on our end, we just do this. And then, yeah, look at I'll keep Oh, so you forgot to update these. Wow. We forgot to. So in here, what I'm going to do is I'm going to call target equals target position is world up, and then just call update. That's better. Yeah. Perspective. Yes. Okay. That's that. Orthographic. Okay. Now let's go in and update one thing of what to do. And let's do it like this. To do. Camera class is basically gone. So camera position, camera forward. No, we don't want you. All we have right now is one thing called the camera. Cam is a camera dot camera. And in here, dot position, we can use the new stuff. So what we're doing is add X, no, add Y. Add this to Y, right? In here, same thing. We're adding minus this. And in here, we're doing add. So we didn't have these helper functions before. Now we do. It's very nice. Add X here and add minus X here. X, Y, Z. So here we're changing the Z position. And so add Z 1. Add Z minus 1. Cam dot position. And then finally in the update, all we have to do is really just do cam dot update, and that's that. And then here we can do cam dot view matrix dot that's it. That's it. Much simpler code. Asserts engine.go engine. Yes, now it's just assert. Asserts this. Okay, anywhere else? Material.go. Materials. Okay, move the S. Mesh. Where's the mesh? So that's because we removed the S earlier. Use here replace all and then update the import path. Now we have buffers. Do this elements. Set it. Oh, I'm GUI. I'm GUI. So I'm GUI is an UI. And same thing. Place all these. Okay. I know. Let's see if the camera works. No, it doesn't. Camera go 41. 41. So this just died because something is null. So we forgot to set one of our values, it seems. Or we called updates view before we set the camera. Oh, right. So we never initialized the camera. We never did that. Look at how many things we have. It's too many. That's why this class was really needed. It's a huge quality of life one. So we removed all the position, all the separate variables, the view matrix, and so on. Now we can also remove the projection matrix. So right now, all of this, I guess, goes away. So this guy is just the camera projection matrix. And I want to take all of these and get rid of. Right now in init, why do we have a projection matrix here? Well, take this here. Yeah, we can do this. So what we'll do is the camera equals camera.new a new perspective position. So where did we start with our position? We're good. I think it was like 0, 0, minus 10. And then target is at 0, 0. So we were looking at the center from the z-axis. And then up is 0, 1, 0. Y is our up. And then near clip 0.1, far clip is 20. FOV and aspect ratio is this. And maybe we can kind of put these on different lines. Right, so this guy is aspect ratio correct, and this guy is FOV. Now far clip and so on. And I think it would make a lot of sense for us to note that this is FOV radians. FOV radians, right? Yeah. And what did we call it? Cam? Cam. So we have this, and then we can do cam.projection matrix this. And that's that. And I guess we are only updating every frame to in case the view has updated. That's it. Resize. Where are we handling resize? Are we even handling that? I don't know. Doesn't seem so. Well, whatever, it's fine. Oh, we still get that camera that go from main 205. So main.go 205. Sure, who calls that first? Init. Oh, we do this only after. Yeah. We create the camera and then we try to use it. Now maybe. Right. Wait, camera position does not change? What? It's like stuck at -10 or something. Yeah, nothing changes. Well, let's look at this guy. And this, that's her. I want to see what our old values were. So we have, so these are all the asserts, and then, okay, so these are our old forward and 0, 0. What happened to the forward? I think we forgot about it. Let's just close these two. Oh, that's why. Our forward was this. I think we can default it to looking on the Z for now. So where do we use it? Do we ever use it? No. I'm not sure that we care about it right now then, because the forward was used to give us a target position. That's it. So maybe for now, I'm just going to comment it out until an actual need comes up. So position, target position. So yeah, so the target for us before was calculated from the camera position +1 plus the forward. Yeah, so position plus forward, which is just +1 on the z-axis, gives us the target. And that's it. Well, oh, an update, we're doing new perspective. Wow, that's not what I meant to do. All we wanted in this case is really, in case the window changes, we wanted, that would mean we want to change the aspect ratio. That's the only thing we want to change, and then update. So for this, and that's why I wanted the fields public and with an update function, we just want this guy. So all we do is aspect ratio equals this camera dot update, and then do this. That's it. In case something changes. So now our camera will actually move. We just need this. Where do we do the look at? Look at target. So where are we passing the target now? Yeah. So +1, this would be like -9. But I'm not sure that this actually matters. Well, let's see. Let's keep this at 0. Now we can actually move the camera. See. Okay. Yeah, now we can move it. But we don't see things. It's okay. New matrix. Okay. So what if this guy is -10, -9? Wait. That is wrong. Okay, let's look at in here. I would actually just call cam.update. These are redundant. Okay. So look at the targets and the rolled up. For us before the, let's see, position was -10, cam forward was 1, and when you add it, you get just -9. Okay, so this part is okay, at least, I think. What else? Updates, so updating the aspect ratio every frame. That's fine. Movement we don't care about. And then this part. World up, I think is correct. And I mean, we can make them give us forward instead of a target, and we can calculate, perhaps. But yeah, this is essentially what we have to do here. And we do need to update the targets here as well. So like camera.targets equals camera.position clone dot add. Let's just do this. Target is this guy, and then target.add z, and we're just going to add +1, and then we'll update. This would mimic now the original behavior. Okay, but why are we still seeing anything? Never as easy as we expect. All right, let's look at main.go for nMage, and then projection matrix, camera. So I think these we have, and let's see, did the view matrix and then update the projection matrix. 500. Okay, so we have very different things from 0.1 till 20. Okay, and then this guy. And then we do a look at, right, from position, target, and 0 and 0. Oh, so there you go. That's a bug. We were setting the view matrix, but not the projection matrix. Now it's correct. Now this should be good. Okay. View matrix should only be set here, right? And projection matrix only here. Okay. Cool. We have this. We have proper zoom, movement, and everything. Amazing. Cool. We did drop a lot of performance. I don't know if it's I'm recording or we're doing a lot of unnecessary work. I mean, the render is not optimized, but where did this go? What are we doing? Okay, I can just move this here. Anyway, so updates we only do when we need. Is it this? Maybe projection matrix. We're now just recreating, we're calling these two extra functions every frame. Is that causing issues? Okay, just remove this. Yeah. Oh my god. Yeah, these are just I guess too much math was being done. So the perspective was from before. We're always calling it an update. It's just the lookat was additional. So I think that's the thing, because aside from that, there is literally no additional work. It's just a class with, with all these things. No additional work, nothing. This is exactly as before, with the clone and all of that. So yeah, I guess this thing. Now we do have, I don't know why we're doing it this way. Maybe this is before we implemented the feature into nMage. But right now, and I think we did it for Flappy Bird, we can get a callback when we resize. So where is the main function? Up. Oh, we're not using that, are we? Resize. Prediction. Yeah, we're not actually. I'm sure it doesn't matter. We're not actually resizing. But yeah, you could use before you run the game. I don't like main being down here, so I'll just move it up to here. So before you run the game, we can do engine dots. Was it event or I always forget this. Maybe input, not inputs. Engine dots. So let's go to run. Game run. So we do call. Oh, we don't. Are we using an all thing? Where is it? Frame start, handle inputs. What? Wait, is this all? Okay, hold on. I could have pushed from a different machine. No? I'm super confused. Or am I looking at the wrong place? I start and then, handle inputs. There were the callbacks. Not in inputs, I'm pretty sure. Event loop starts. Where is it? That's super weird. That is odd. I'm not in a wrong branch or something, am I? That'd be so weird. But no, this is the only branch we have. So engine handle inputs. Oh, there we go. Fire callbacks, event callbacks. There we go. In engine.go. Okay, where's it? Engine.go. Okay, yeah, event callbacks. So we can do engine, but how do we add a callback? Register. Oh, it's on window, is it? Window. Oh yeah, makes sense. Okay, so the callbacks around the window. I completely forgot. We'll soon probably need some docs or more examples. But yeah, so we can just add a function, and we say just call this function when you have an SDL event, essentially. And this is always done before updates. So we can actually look at what is this? Not run engine. So in handle inputs is done before the update call, right? And so we can get, here are the events sent by SDL. So we send them to you, then we process. Thing is, yeah, we can use it, and we can only handle, for example, window resize if we want to do this. I mean, for the sake of completeness, we might as well. So we can do handle inputs yeah, window events, right? And we have an SDL event coming in. Right, so we just, all we have to do is append it to the window, just give it a function or a bunch of functions, and it would call all of them. And then we can switch on this guy, but all we care about really is this. We don't care about anything else. Right, and if it did change, what we can do is what we had here, this. We can recalculate, we can update the size. Right, get the new size, and then camera aspect ratio equals this guy, and then camera.update, and I think that's it. That should do it. I should do it. Yeah, let's see. Let's see now. So far good. Resize. Yeah, looks okay. No weird stretching or anything. Yeah, you can see kind of zooms in. Wow, we're so far to be on this set. Yeah, I think this is it. I hope we're getting the updated sizes. Although I think this guy in like data or something gives us the thing. I think it does. Size changed. Yeah. So width and height is this. So it's sent in the event. To be safe, I guess we can take it from them, from the event itself. And yeah, let's do data 1. data to update and update this. Okay. That's it. I think this is pretty good for today. We have our camera class. I've been putting this off for a long time. I didn't want to deal with it, but you know, it's good to have it out of the way. Nice. Very nice. Okay, and I think that's it. I'm going to, yeah, we have now a cert and a camera package, and we did sounds for Flappy. So right now I'm not going to add any sound package to nMage unless we think there are some, you know, engine specific features we want to do. Otherwise, you can just import Wavy and start using it or something else. So you can do camera package plus rename certs to cert, and that's it. Okay, thank you everyone, and I'll see you next week hopefully.